Horizontal and oblique asymptotes. So it's very important that we learn the rules of horizontal asymptotes primarily for this course. So here's the three rules. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is always at y equals 0. So what I mean by degree, remember, is the highest exponent on any variable. So there's no exponent here, so this would be degree 0 over degree 1, because this would have an exponent 1. So the degree in the numerator is less than the denominator, so it's y equals 0. Here we have exponent 1 over exponent 2. So again, the degree in the numerator is less than the degree in the denominator, so it's y equals 0, which is why when we had our graphs of y equals 1 over x, we was safe to say that y equals 0 was our horizontal asymptote. Now that means it's in this form. So we would have to divide if we wanted to put it in y equals a over x minus h plus k form. So those rules apply when you just have your rational expression in this form with one term over another term. Rule 2, if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. So if the highest exponents are the same, then it's the leading coefficient, so 2 over 1. So the horizontal asymptote would be y equals 2 over 1, which is 2. And then the final rule would be the only other scenario that could happen is if the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. So if this is x to the third degree over second degree, you would have no horizontal asymptote. Now it is possible for oblique asymptotes to be in some graphs, and you're going to notice that in some of the graphs that we analyze. I'm not going to ask you to sketch those graphs, but we will look at the asymptotes. So an oblique asymptote, oblique meaning an angled line. So I just drew a picture of a graph here, or have a picture of a graph so you can see it can have a vertical asymptote and an oblique one instead of a horizontal asymptote. This is going to happen if the degree in the numerator is 1 more than the degree in the denominator when the expression is simplified. So you may have to factor and cancel and things like that. That's when there's an oblique asymptote. So if we had the same one we looked at here, we have this degree is 1 more than the degree in the denominator, then that is why there's an oblique asymptote. Now, if the equation has already been divided out, this is what would happen. Where your k value would be x minus 1, but that's actually going to tell you what the oblique asymptote. The oblique asymptote would be this tail end, so it would be y equals x minus 1, which would be an angled line if you think of y equals mx plus b form. So that's why you're going to have the equations of oblique asymptotes look like that.